Hello, geometry students, and welcome back to video number 2. Now, just make sure that if you haven't seen the first video to this that says lesson 0, go back and watch it because you're going to be lost, and I don't want that to happen. So again, make sure that if you're watching this video, it's because you've already watched the first video, the lesson 0. Okay, now, I'm going to be very straightforward with this. When we're talking about trigonometry, we can't actually do anything without knowing these things called trigonometric ratios. Yeah. Make sure to write this down. It's actually very, very, very important. Okay. Now, it's not going to make sense to you right now. I'm telling you right now. Just follow along with me, okay? You cannot do trigonometry without knowing SOHCAHTOA, right? It sounds weird, but this is actually going to save your grade for trigonometry. You can't do this without SOHCAHTOA, right? And this is what I mean by SOHCAHTOA. Write it down. Literally, SOHCAHTOA. SOHCAHTOA. Now, this is actually an acronym that stands for things. And I'm going to tell you what it means. Each letter in this acronym stands for something, okay? The S, you will never guess. The S stands for sine. And maybe now to make sense, all like in your calculator, it says sin, S-I-N. That's actually what this means. So the S stands for sine, right? The C stands for cosine. And the T, no, it doesn't stand for cosine. It stands for tangent. You thought you knew it, huh? Tangent. Okay, and I'm going to break it down one by one. So, basically means that the sine is equal to O over H. Now, if you saw the first video, it'll make sense now, or you should know what the O and the H stand for, right? So, the O stands for, yeah, you guessed it, opposite. Opposite. And the H, let's see if you can get it. The H stands for, yeah, hypotenuse. Dojo points for whoever guessed it. Hypotenuse. Okay, and it's just an acronym to help you remember this, right? So when you're talking about the sine, it equals to the opposite over hypotenuse. Again, I know this doesn't make sense right now, but it sure is going to make sense once we start doing the problems, okay? Now, the cosine always equals to A over H. And again, if you saw the first video, it makes sense that the A stands for adjacent. And yeah, the H, we already know, stands for hypotenuse, right? Now, the last one is the T for tangent, right? Now, the T is still the same thing. T tangent equals to O over A, which basically means that the tangent is equal to the opposite over the adjacent. Now, these are the basic 3 trig ratios that you're going to be dealing with in this unit. You might not know how to use them now, but you will eventually. So I'm going to go ahead and actually, you pause the video right now. Make sure that you have this written down, because if not, you're going to be lost and you're not going to know what's happening in the next problems, okay? I'm going to assume you've had enough time to write this down. Now, I'm going to show you how we're going to use this in actual problems, right? Okay, so now I'm going to show you how to actually use these trigonometric ratios to answer questions like number one. So before you even do anything, I would highly suggest start writing down those trig ratios. Write down the SO, the CA, and the TOA. And that's just for you to get used to it because if you don't know these, then you're not going to do well in this section. Okay, so if you look at number one, it literally just says tan z. Okay, and what this basically is saying is what is the tangent of angle z? Now, it sounds like a weird question, but you actually know how to answer this. And it's basically using these three trig ratios. What I'm going to do down here is I'm going to rewrite this problem just so it says tan z. Now, tangent of z is equal to one of these ratios, okay? And the hardest thing you have to do is basically identify which one is the ratio you have to use. Um, and if you were paying attention in the last slide, you should know that the ratio you're going to use is the opposite over the adjacent. And I'm not making this up. The reason why I'm using this ratio is because we know that the tangent is equal to the opposite of adjacent, right? So this is where this is coming from. Now, the only other thing that you have to do now is basically just figure out, well, what's the opposite and what's the adjacent, okay? Since we're talking about angle Z, we're going to label this triangle in terms of angle Z, right? Now we're specifically looking for the opposite and the adjacent. So right off the bat, if I'm looking at angle Z, the opposite will be, well, this, right? 21 is the opposite. So we already know that the opposite is going to equal 21. But now we have to look for the adjacents. Now, if I were you, I would label all of the parts because at the end of the day, it's really going to help you out. And the hypotenuse is probably the most straightforward because just identify your right angle and that's going to show you what your hypotenuse is, right? So the hypotenuse is equal to 35. And the only one that we're left over with is this one, right? Which means that the adjacent, the side that is adjacent to angle Z, is just 28. And look, that's what we were looking for. We were looking for the adjacent side. So to answer this question, the tangent of Z is just 21 over 28. And that's it. That's literally your answer. So these are the steps you have to take. If you need to see another example, well, look at this one right here, number two. Again, the first thing you want to do before you do anything is write down your SO, your CA, and your TOA. Okay, this problem is asking you to find out what is the value of the cosine of C. So I'm going to rewrite that down here. They're asking us what is cosine of C equal to? Again, it's going to be equal to one of these three ratios. You just have to identify which one it is. And yeah, if you guessed it, it is this one. And again, that's just because C stands for cosine. So I'm going to use the ratio that is equal to that one. Okay, so right here, I'm going to put A over H. Now your job is to figure out, well, what's adjacent? Because remember the A stands for adjacent and the H stands for hypotenuse. Well, what's adjacent to angle C? Well, let's figure it out. Looking at angle C, if I want to find the adjacent, I would find the hypotenuse first, right? So remember the hypotenuse is the side that is directly across the 90-degree angle, which in this case is 34. So we've already found the hypotenuse. The hypotenuse is 34. Let me erase that. hypotenuse is 34. The side opposite is 30. We don't really need to know that, but I'm just labeling them all just to label them. The one that we do need to know, though, is the adjacent. And the adjacent, based on this picture, is your 16. So the answer to this ratio, the cosine of C, well, that's just 16 over 34. Let's do one more together. Well, again, before you do anything, write down your so, ka, toa. This problem is asking us to find what is the sine of C, right? I'm going to rewrite it here, the sine of C. Based on these three ratios, the one that I'm going to use is this one, because again, the S stands for sine. So the sine of C is going to be equal to the ratio of your opposite over your hypotenuse. So go ahead, we're looking at it from the angle of angle C. The side opposite of angle C is 28, right? So this is equal to 28. And the hypotenuse, well, first identify your right angle. Your hypotenuse is the side directly across from that, which is 35. And that's it, people. The sine of C is just 28 over 35. So the difficulty in these kind of problems is identifying which ratio are you going to use and labeling the triangle correctly. For this last problem, what I would want you to do is try to answer these on your own. So this is the time that I would recommend you to pause the video and try to see, can I get numbers 1 through 6? Go ahead, pause the video, try it out. So if you're watching this now, it's because you've unpaused the video and you're just here to check your answers. And I'm just going to go fairly quickly because you're just checking answers, right? I'm going to do 1 through 3 first because 1 through 3 is asking for angle N, right? So if I were to label this from angle N, my opposite is this, my hypotenuse is this, and my adjacent is this. And again, before you start, you want to write down your so, ka, toa. Number 1 is asking for the cosine of n. And like we said, the cosine is just your adjacent over hypotenuse. I'll write it here. Your cosine of n is just your adjacent over your hypotenuse, which based on this picture is 9 over 15. Number 2 is asking for the sine of n, which using these trig ratios is opposite over hypotenuse, which is just 12 over 15. And number 3 is asking for the tangent of n, which again, using these three trig ratios, is just going to be your opposite over adjacent, which is equal to the ratio of 12 over 9. So again, this is just for numbers 1 through 3. You should have gotten this. And you could have reduced if you want, but I'm not really asking you to reduce. Just as long as you can get this, that's fine. Okay? Now, the tricky part about 4, 5, and 6 is the fact that you actually have to relabel your triangle. Because now instead of looking at it from angle N, you're looking at it from angle P. So I'm going to go ahead and erase the marks because now I'm looking at it from angle P. And based on angle P, well, my opposite is 9. My hypotenuse is still 15, but my adjacent is 12. And pretty straightforward. Number 4 is asking for the sine of P, which based on the SOHCAHTOA is equal to the ratio of opposite over hypotenuse, which is just 9 over 15. For number 5, we're looking for the cosine of P, which based on these trig ratios is just adjacent over hypotenuse, which is equal to just 12 over 15. And the last trig ratio they're asking us for is the tangent of P, which is equal to the opposite over the adjacent, which gives us 9 over 12 as an answer. If you were able to get this on your own, then that means you're ready to do the practice problems that we assigned for you. If you're still struggling and for some reason you still have questions, feel free to email me and I will try to get back to you as fast as I can with an answer to your problem. Other than that,